Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on single-phase AC voltage controllers. So first, what do you mean by single-phase AC voltage controller? So its another name is the AC voltage regulator. We can call it as AC voltage, single-phase AC voltage regulator. So it is a static power electronic circuit. It is a static power electronic circuit. What is the definition of AC voltage controller, which converts from AC to AC, AC to AC, fixed AC to fixed AC to and variable DC, variable AC, variable AC. But here frequency is same, input frequency and output frequency is same. So without change in the frequency, it will convert from fixed AC to variable AC. So here, what are the applications? In what applications we will use this single phase AC voltage controller? In the heating and lighting circuits, and after the speed control of AC machines and fan regulators. In the fan regulators and similar to applications of auto transfer. It is like a auto transformer, fixed AC to variable AC. So now here these are the classification of AC voltage regulators, AC voltage controllers. First one is a half wave and second one is a full wave. First I will explain single phase half wave rectifier was AC voltage controller with R load and L load. After that I will explain single phase AC voltage controller with full wave R and L load. In this we will use thyristor and diode in parallel, anti-parallel with diode, that we will apply across AC. AC voltage is applied across this circuit. But here two thyristors are connected, anti-parallel thyristors are connected in parallel. Again this AC voltage is applied across this circuit. So this is full wave and this one is a half wave, and here is load is connected. So the first I will explain single phase half wave AC voltage controller with R load. So this is the circuit diagram of single phase half wave control AC voltage controller in this T and diode. So here two switches, thyristor and diode, are connected in anti-parallel and supply is given to this circuit, and this is the load. Here load is the R load. Here load current is I0 and load voltage is a V0, supply voltage is a Vs. So now here what is the operation here? So here we are giving the Vs equals to Vm sin omega t supply, AC supply we are giving. So how it will operate? So now if you see the waveforms, so first here we are giving the so if you give the AC voltage and what are the waveforms? Supply voltage and gate current pulses and output voltage, output current. So this is the AC voltage, Vs equals to Vm sin omega t. We are giving the supply voltage Vs equals to Vm sin omega t. This is a Vm maximum value, and now here this is the Vm maximum value. Now what are the operations here? So during positive off cycle, during positive off cycle, during negative off cycle. During positive off cycle, so SCR T1 is in forward bias, and next here during negative during in this diode is in forward bias, and in this diode in reverse bias, and in this thyristor is in forward blocking mode, for reverse blocking mode. That I will explain first. In the first, these are the first one, 0 to alpha, from 0 to alpha. So what will happen? Supply voltage is positive and gate current is 0. We are not giving any gate current, IZ equals to 0. So we are giving positive gates, positive supply is given to this circuit. So what will happen? This T is this thyristor T is in forward blocking mode, and now here this diode is in reverse bias, because here we are giving positive supply. So plus and minus, here minus and plus. This is in forward bias and it is in reverse bias. So now here what will happen? So here output voltage equals to supply voltage. It is a open circuit, it is short circuit, current is flows from here in this. So now here, so both are in forward bias. So both one is forward bias, but it is in forward blocking mode. We are not giving any gate supply. So this is open circuit, this is open circuit. So open circuit current is 0, means I naught is 0. I naught is 0 means V naught equals to I naught into R. So V naught equals to I naught into R, that equals to 0. So here, so next case. So what will happen from alpha to pi? We are giving the gate pulse, positive gate current. So Ig is greater than 0. What will happen from alpha to pi? So now here supply voltage is positive and gate we are giving gate current. So now here, so this SCR is in forward conduction mode. We are giving the gate pulse at alpha. So SCR is in forward conducting mode. Diode is in reverse bias. Current will flows from through SCR thyristor and through diode through load. So now here this output voltage equals to this supply voltage V naught equals to Vs and I naught equals to V naught by R. So now here this is next case here from pi to 2 pi. From pi to 2 pi. So this is a pi and this is a 2 pi. Here this is we are applying the negative. So this is the positive and this is the negative. So now here next case from pi to 2 pi. Here this is a reverse minus plus. So this is a minus and this is a plus, and this is a plus and this is minus. Thyristor is in reverse blocking mode, and next here this diode is in forward bias. So now here this one and diode is in forward blocking mode, and V naught equals to Vs and I naught equals to V naught by R. If you see the waveforms, these are the waveforms, input to output voltage and output current. So now here what will happen? This is alpha and this is a pi, this is a 2 pi and this is a 2 pi plus alpha, same fashion here. So now here from 0 to alpha, so V naught is positive. So thyristor T1 is in forward blocking mode and diode is in T1 will conduct, and here T1 will only conduct, D1 is off, D is off, T is on. And next here in this case, so here T and D are both are in off. So 0 to alpha, supply voltage is greater than 0 and there is no applied gate pulse, and here from alpha to pi we are giving gate pulse. So T1 is in forward conducting mode, diode is in reverse block. Supply it will follow the supply voltage and current is also follows the supply voltage. And during negative off cycle, so now thyristor is in reverse bias, reverse blocking mode, and now T is off and diode is on. So diode is in forward bias. So T1 is on and D is on. So it will follow the supply voltage, and next it will follow the current V naught by I naught. This is V naught by R. So this is the output current, this is the output voltage, and this is gate pulse, and this one is the supply voltage. And now here, what is the average value? How you will calculate the average value? Or average value we can calculate. This is a pi, this is a 2 pi. So here T1 is T is conducting from 0 to alpha to pi, and diode is conducting pi to 2 pi. So here this this is not symmetrical waveform. So here it is conducting from alpha to 2 pi, from alpha to 2 pi. Total time period is 2 pi. So this is a Vs. Vs equals to Vm sin omega t. So now here if you simplify this one, so now this is minus cos omega t. This is Vm common. So from alpha to 2 pi. So this is cos alpha minus 1. So now here V naught average equals to Vm by 2 pi. cos alpha minus 1. And next here average output current equals to this one equals to divided by R. So this average output voltage divided by that resistance. This average output voltage is this one. So this one is the average output voltage, and Vm by 2 pi R cos alpha minus 1. So now how we will calculate the RMS value. RMS value of output voltage equals to, so it is conducting from alpha to 2 pi, from alpha to 2 pi, square root under root, this is the time period t. So Vs square d omega t, Vs equals to Vm sin omega t. So now here if you simplify this sin square theta Vm square by 2 pi, sin square theta means 1 minus cos 2 omega t by 2. So now here Vm by 2 under root 1 by pi. So if you simplify this one, 2 pi minus alpha plus sin 2 alpha. Now here what is the output RMS value of output current equals to this V0 RMS divided by R. So now here this is the Vm by 2 under root 1 by pi 2 pi minus alpha sin 2 alpha 2. This divided by R means that is I0 RMS. And now here output voltage, output power equals to V0 RMS square by R, I0 RMS square by R. Just substitute in the RMS value of output voltage and output current in this, you will get the output power, that is P0. And now input power factor equals to, what is the formula? So input power equals to output power. So now here input current equals, input power equals to supply voltage into Is into the cosine angle between voltage and current, that is cos phi, that is input power factor. And now here output power factor already we have calculated, we derived in the previous slide. So that is V0 RMS square by R or I0 RMS square by R. But here Is equals to I0 RMS. So you can cancel these two. So now here I0 RMS into R divided by Vs. So that is the input power factor, that is the cos phi. This is input power factor, that is the cos phi. And now here conduction time. So here thyristor T1 is conducting from alpha to pi, and now that conduction time is the pi minus alpha. This during this duration only T thyristor will conduct. And next here from pi to 2 pi the diode will conduct. So the diode will conduct so 2 pi minus pi means that is the pi. So conduction time for the diode is the pi. So now here peak inverse voltage is the Vm. So now here circuit turn off time. So time for which the SER is in reverse bias. So now here that is pi minus alpha. The time circuit turn off means omega tc, the time for which the SER is in reverse bias. So that I think this is not pi minus alpha, pi by omega. So now here during this duration only SER is in reverse bias. So here 2 pi minus by omega, that is pi by omega. And now second one is a RL load. During RL load, so how it will works. So now here, so one extra inductor is connected, R and L load. So here I am explaining about single phase half wave AC voltage controller with RL load. So now here the load is RL load. Here in the RL load, how it will works. So now here from alpha to pi. So here in this duration T and D both are in off condition. Okay, na? So now here, so that I will explain. So first alpha to pi. From alpha to pi, Vs supply voltage is positive, and here pi to 2 pi supply voltage is negative. So supply voltage is positive. We are giving the gate pulse Ig is greater than 0. Ig is greater than 0 means here we are giving the positive supply and we are giving the gate pulse Ig means this thyristor will conduct, and this diode is in reverse bias minus and plus. The diode is in reverse bias, that is in So T1 will conduct, so diode is thyristor is on and D is off. The thyristor is on and diode is in. Thyristor is in forward conducting mode and diode is in for reverse biased mode, and out it will follow the supply voltage. So up to pi, from alpha to pi, and I naught equals to this, I naught equals to this is, it will reaches to the maximum value, again it comes back to, it is up to pi. So now here from pi to beta, so here power is delivered from the source to the load inductor here in from alpha to pi. Inductor stores the energy in the form of electrostatic magnetic field, so that is delivered to the load from pi to alpha. So now here current will decreases, so power is delivered from load to the source, and now here in this case also the thyristor and both diode both are in forward bias. So now here V0 and Vs, so V0 equals to Vs, it will conduct up to this much angle up to beta. So now here from beta to 2 pi, beta to 2 pi, beta to 2 pi, beta to 2 pi, so supply voltage is negative, so the diode is in forward bias, and next thyristor is in reverse blocking mode. Reverse blocking mode means that is T1 is off and diode is in on, so here there is a negative current flows. So this is the circuit diagram for RL load. So now here what is the average value? This is the alpha, this is a pi, and next here it is a 2 pi and 2 pi plus beta up to beta. So now here this is the 2 pi plus alpha and this is the beta. So now here how it will works from 1 by 2 pi average value 1 by 2 pi from alpha to 2 pi Vm sin omega t, so from alpha to pi, so sin omega t d omega t, again so from alpha from 0 to beta Vm sin omega t. So this is the average value, and next RMS value, how we will calculate? RMS value equals to, so 1 by 2 pi 0 to 2 pi, so here it is divided into Vm sin omega square dt. So now here this, here from 0 to beta and next alpha to 2 pi, so here under root Vm by 2 pi from 0 to beta Vs square d omega t plus from alpha to and 2 pi Vs square d omega t. So this is the case. So now here Vs equals to Vm sin omega square theta. So now your final conclusion is Vm by 2 under root 1 by pi, pi plus beta minus alpha plus sin 2 alpha by 2 plus sin beta by 2. So now here these are the output current waveform. Here you will not get any current here, any current. So during this period from beta to alpha. Now here single phase full wave AC voltage controller. This is important. So here two thyristors T1 and T2 both are in forward, both are connected in anti-parallel connected T1 and T2. So here T1 and T2 with R load I am explaining. Here supply voltage we are giving. Here you will get the output V0 and I0. Here this is the input supply voltage Vs. This is a Vm. Vs equals to Vm sin omega t. First 0 to alpha. So both are in T1 and T2. Both are in off. T1 and T2. Both are in off. So here is also T1 and T2. Both are off condition. So now here it is in T1 is in forward blocking mode and T2 is in reverse blocking mode, and V0 equals 0 and I0 equals to 0. This is a V0 equals 0 and I0 equals to 0. And next here Next case, here from alpha to pi, alpha to pi, from alpha to pi, from alpha to pi. This is the alpha. Trigger the SCR T1. So Ig is greater than 0. Now here Ig is greater than 0 means what will happen? So T1 is forward conducting mode and T2 is in reverse blocking mode. So T1 is forward conducting mode and T2 is in reverse blocking mode. Here T1 will trigger. So T1 thyristor will conduct. So T1 is the supply voltage. This one up to, it will conduct up to pi duration. It will conduct up to pi duration. Now what about the I naught? I naught equals to V naught by R. So this is the V naught by R. So V naught by R. So now this is the case for this is here T1 thyristor will conduct. This is the thyristor T1 current only from pi to pi plus alpha. So pi to pi plus alpha. So T1 is in reverse blocking mode and T2 is in forward blocking mode. So here T1 and T2 both are in off mode. So here there is no output voltage and output current. And next here from alpha to pi, from alpha to pi, what will happen from from pi plus alpha to 2 pi, from pi plus alpha to 2 pi. So T2 will trigger. T2 will be in forward conducting mode. T1 will be in reverse bias. So T2 is on, T1 will be off. This will follow the supply voltage and that I naught equals to V naught by R. So this is the case. So this is the output input voltage. So this alpha 1, alpha 2 and next output voltage and output current. So now here from 0 to pi duration T1 will conduct and next pi plus alpha to 2 pi duration T2 thyristors will conduct. So now here if you see the average value, how we will calculate the average value? So now here it is a symmetrical waveform. So this is a 2 pi, half is a pi. So now here positive half and negative half is same. So here it is a symmetrical waveform, output voltage and output current. So I naught and V naught equals to 0. So I naught average value and V naught average value equals to 0. For any full wave AC voltage controller with any type of load, so that average value is 0 because here the you will get the here symmetrical waveform. For any symmetrical waveform the average output value is 0. So now here V naught average value and I naught average value, because here this is 2 pi, this is our what do you mean by symmetrical waveform? Symmetrical wave, positive half, negative half must be same. So here positive half and here negative half is same. So it is a symmetrical waveform. So the average output voltage and average output current both are 0. And next, how we will calculate the RMS value? Here RMS value, here you can take up to 2 pi also, but here I am taking half duration because it is a symmetrical. So 1 by pi from alpha to 2 pi. Otherwise you can take 2 by 2. So from 2 pi also Vm square sin omega square d omega t from alpha to. You can write like this also from 1 by 2 pi. So from alpha to pi and next to pi plus alpha to 2 pi Vs square and here Vs square d omega t plus d omega. This is also same this equation. And now here V naught RMS equals to Vm by root 2 1 by pi. This Vm, this is 1 by pi, pi minus alpha 1 by 2 sin 2 alpha. So now if you divide it by R, you will get the I naught RMS, that is Vm by root 2 R. So that is under root. So under root 1 by pi minus alpha plus 1 by 2 sin 2 alpha. So this is the case for single phase full wave AC voltage controller with R load. And now here single phase full wave AC voltage controller with RL load. So this is the this is the thyristor. This is the thyristor. So here T1 and T2 thyristors will conduct. So it is also here from 0 to alpha, from 0 to alpha I will explain later, from alpha to pi duration, from alpha to pi duration, from alpha to pi duration. Supply voltage we are giving positive, and next Ig we are giving. So here plus and minus we are applying. So now here this T1 thyristor will conduct. So here T1 thyristor will conduct, and T1 is in forward blocking mode and T2 is in reverse blocking mode. And next V0 equals to Vs, it will follow the supply voltage, and next I0 equals to V0 by R. So it will conduct up to here. And next here, what about pi to pi plus beta? Pi to pi plus beta. So here pi to pi plus beta up to this one. This is a beta. So here pi to pi. So inductor. So here inductor stores the energy in the form of a magnetic field from alpha to pi. After that, this inductor delivers the power from the source to the load, from the load to the source. So in that case, so here this is the because of inductance only up to beta. So this thyristors will conduct. So here current is decreasing up to beta only. So up to beta only. So this is the case for from alpha to beta. So in this case, so T1 is forward conducting mode and T2 is in forward reverse blocking mode. And next from beta to pi plus alpha, beta to pi plus alpha. So both are in reverse bias. Both are is in reverse blocking mode. There is no output voltage. So V0 equals to 0 and I0 equals to 0. So there is no output voltage. From pi plus alpha to 2 pi, from pi plus alpha to 2 pi, T2. So we are giving the gate pulse here. We are giving the gate pulse here. So this is alpha 1 and alpha 2 for thyristor T2. And now here T2 will conduct. So T2 is in forward conducting mode and T1 is in forward blocking mode. So in this case, output voltage equals to Vs and I0 equals to, so this one, I0 equals to V0 by R. So now here there is an angle. So phi equals to tan inverse omega L by R here. So here phi, that is depending upon the inductive reactance and resistance. So in this way, now here what about this average V0 average equals to, it is a symmetrical waveform, positive of and negative of is same. V0 average is equals to 0 and V0 RMS equals to 2 by, so this is up to beta, alpha to beta, from alpha to beta. So here up to half cycle I am taking. So 2 pi total time period, to only a half cycle. So 2 Vs square means Vs equals to root 2 into Vm. So that equals to 2 Vs square sin square omega t. So that is Vm sin omega t. Now here V0 RMS equals Vs into 1 by pi beta minus alpha plus sin 2 alpha by 2 minus sin 2 beta by 2 under root. So now here this is a I0 RMS square. I0 RMS equals to Vm by root 2, Z equals to Z. So here phi equals to tan inverse omega L by R and Z equals to R square plus omega square L square under root. So now here 1 by pi alpha to beta, from alpha to beta. So sin omega t minus phi. So here from alpha to beta, sin omega t minus phi minus sin alpha minus phi exponential of R by L alpha by omega minus t whole square d omega t. So here this is under root. So this is the RMS output voltage. I hope all these concepts are clear to you. regarding single phase AC voltage controller, half wave and full wave. Here half wave means unidirectional and full wave means bidirectional. So I hope all these concepts are clear. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.